the introduction of a new ID system. New ID system following its experience from the COVID-19 pandemic. Starting 2021, all staff and patients of the hospital shall be required to carry a chip and PIN card called a MasterCard. This will be a smart card bearing information such as the bearer's personal details, department, assigned units, health insurance records, medical conditions, medications and prescriptions, and emergency cards. The MasterCard can also be used as a debit card to make payments anywhere within the hospital for services used or products purchased. Hospital administrators and staff are excited about the new ID system and the security it will provide, as well as the revenue potential it will generate from patients. They have, however, not carefully thought about the process of issuing approximately 100,000 cards covering all staff and patients. Granted that 120 applicants can be processed in 5 hours. What is this question about, class?
Productivity.
Productivity. Yo. Granted that 120 applicants can be processed in 5-hour day. The entire 100,000 staff and patients could be issued the cards within the estimated time. The activities covered within the process and approximate activity times are given as follows. Activity 1 must be completed before activity 2. Activity 1 must be completed before activities 2 and 3. Activities 4 and 5 are preceded by activities 2 and 3 respectively. So you see, instead of giving you the table, providing you with a table and telling you that this is the work element, this is the predecessor, we are giving it to you like this. We want to test how smart you are. Okay? Activity 6 follows completion of activities 4 and 5. The predecessor activities for 7 and 8 are activities 7 and 6 and 7 respectively. A description of the activities and durations are presented in the table below. So this is the duration. These are the activities, up to 9 activities. These are the description of the activities, and this is the duration. So our first question is, draw the precedence diagram for the process. Draw the precedence diagram for the process. And it's so simple. You are doing this for 6 months. 6 months. What is missing from this diagram? From what you have learned, what is missing from this?
The activity time.
The durations are not there. Yes, the activity times are not there. The activity times are not there. Design a process with minimum number of workstations that would achieve the daily production target without violating the precedent constraints. This is a whooping 11 marks. So our answer is that we want to calculate the design cycle time, and this design cycle time, the formula is production time over design units of output. Why are we having 5 times 60 to get a 300 as the time available?
You want it in minutes.
Okay. But where from the 5? Where from the 5?
It's probably given the question as 5 hours.
No, it's here.
5 hour day, yeah.
5 hour day, which means a day is made up of 5 hours. Okay. So 5 times 60 will give us, and then the 120 is also up there. You do this, you get, 1 mark. And the CD, design cycle time, is 2.5 minutes. And for the minimum number of workstations, we total the work element times divided by the design cycle time, and that gives us roughly 2.8. Okay. It gives us 2.8. So what, roughly 3 workstations. That, check out your 2 points, correct. And then the assembly line diagram, putting that into the into workstations. You have this. Okay. Is it possible to issue a card per applicant every 5 minutes, and why? That's the next question. And it says no. The flow time is 7 minutes. This is the minimum time required to get an applicant. How do we get the 7 minutes from here? How do we get, we said the flow time. The flow time is the total amount of time that the product will go through the various stages and come out. So why is the flow time 7 here?
You sum up the time for the 3 sessions. So 2.5 plus 5 plus 2 gives us 7.
Yeah. So this is a very cheap 3 marks. Very cheap 3 marks. Is it we issue a card count every 5 minutes, and why? So the answer is no, because when an applicant enters the system, it will take the applicant 7 minutes to come out of it. You see. Now the purpose of doing what I'm doing here this evening is not to show you how difficult the questions are, not to show you how easy the questions are, just to make you appreciate the way we draw the marking scheme, so that you don't miss out details. It is the details that will fetch you the marks. You see that the marks are very tiny, tiny, tiny. So if you leave out details, look at this, look at this. I'm sure somebody will not even think about bringing this, but that calls for 2 marks. Whereas even on your question paper, you can do the summation there. So, but that is 7 divided by this, and quickly do this. But if you leave this out, see, you have missed 2 marks. So those important details, please don't leave them out, like this one. Okay. And then the next one is the one by Baby Jet Airlines. Another interesting question. See, this is 0.5 mark, 0.5 mark. So please make sure that every necessary detail that you need to bring it out, so you don't lose out on some of these points. After all, when you are short of scripts, we can give you supplementary sheets. So take note. All right. So I'll stop sharing. Any questions so far? No question. Okay, so let's go to the slides and finish up for the semester. I know we are all tired at 11 weeks. Is my screen showing now?
Yes.
Have I lost the class? Class, can you hear me?
Sir, it's showing.
Yes, sir.
It's showing. Okay, it's showing. Who wrote down the last slide we got to? Who can remind us? Abu Hassan Farid. Abu Hassan Farid, are you there?
Yes, sir.
Your name sounds like a foreigner in my class. This is the first time I'm seeing this name. Are you regular in the lectures?
Yes, sir.
Mm.
Yeah, even last
I'm
week,
surprised that
my performance was the one you kept first when you're displaying our results.
Okay. 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 So where did we get to? Leonie.
So we ended at outsourcing.
We ended at outsourcing, which is
Yes,
3-2.
I forgot to jot it down.
You forgot to write that down. Okay. Okay, so I think we'll pick it up from, did we talk about e-procurement?
No, sir. I think we ended at outsourcing. We spoke about testing products, temporary lack of plans, blah, blah, blah. That's where we ended.
Page 322, yes.
I did explain what single sourcing is, what multiple
sir.
sourcing is.
Yes, sir.
Okay, so then we jump to e-procurement. So e-procurement deals with the direct purchase from suppliers over the internet. Now, usually when organizations are doing procurement, it goes through a process. And that process that organizations follow takes resources, takes money. So for example, organizations that still do the manual purchasing, each departmental head will have what we call the not a voucher. I've forgotten the name. But you have those documents that you would indicate your requirements, and then you send it to the procurement departments for them to assess, and if it's acceptable to them, they will go through the process and buy. And for some items, they would need to go out there, get about three pro forma invoices, come and sit back in the office, do the evaluation, and then they select. But if for any item at all, we are going to go through all this process to get an item that would cost the company as low as, say, 20 cedis or even 50 cedis, then we may be spending more than we may be spending more on the procurement process than what we are actually procuring. And this is where e-procurement comes in handy. The e-procurement is good for buying what we call low-value items. And it is the direct purchase from suppliers over the internet. It has the following benefits to SCM. SCM stands for supply chain management. It lowers the transaction cost related to the purchases. That's what I've just explained, that every procurement you are making, there is a transaction cost. For some items, you need to advertise. I mean, if we are going to go to the national procurement system, for some items, you will need to advertise into popular newspapers. newspapers that are in wide circulation, and advertising in a newspaper for a day, if you know the cost. These are all parts of the transaction cost of procuring the item. But if we follow the e-procurement system, we are able to lower this transaction cost that is associated with purchases. We are also able to lower prices of goods and services because over the internet, we can have varied opportunities, a lot of options to select from. So we are able to lower the prices of goods and services. We are also able to reduce labor and clerical costs. Well, that is also part of it, part of the transaction cost anyway. So reduce labor costs and faster ordering and delivering times because we are using the electronic system. Ordering becomes faster and delivery is also fast-tracked. Then distribution. This is the actual movement of products and materials between locations. So moving products from one location to the other. We call that distribution. And its management involves managing and handling of materials and products and receiving docks, storing the products and packaging, then shipment of the others. In a typical central distribution systems, normally central distribution systems are run by retailers. So in a typical central distribution system, that is where suppliers will be required to deliver their supplies. And then they are consolidated in the central distribution center. And then from there, items are shipped out to individual retail outlets, depending on their requirements. And that process of accepting supplies from suppliers, keeping them for a short while, and moving them to the required destinations in terms of retail outlets also takes a lot of money that needs to be properly managed. Even in handling, I mean, in the storage and handling process, if you don't take care, you incur a lot of losses. So a lot of planning also goes into distribution. But apart from the central distribution system that we are talking about, many organizations also have warehouses, which works on similar principles. We produce, market may not be readily available. We keep it in the warehouse, and then we move the output out to customer destinations as and when we receive orders. So that ability to move and moving goods to their final destinations involve using appropriate trucks, using appropriate packaging, using appropriate mode of transportation. All these go into the concept of distribution, the actual movement of products and materials between locations. And managing this involves all these activities that we have talked about. A key focus of distribution is order fulfillment. What is order fulfillment, class? What is order fulfillment? Order fulfillment. Leonie.
So I want to try. Ensuring that you meet the demands of the clients. Like the order the delivery should meet the complete order of demands of the clients. Yes.
I like the word complete order of the customer. Now, what goes into that completeness? What goes into that completeness? Before then, Sadiq Ahmed, your hand is up. Do you want to add to what Leonie said?
I want to continue from which.
Oh, sorry.
How to continue?
Continue, please.
Okay, so I would say it's it's fulfilling the sales order of the customer. Maybe like the customer can tell you, I want this particular specifications and all that, and then you as a customer, or you as a producer, you distribute exactly what the person wants. So the focus of was changing. Yeah. So order fulfillment has to do with the supplying what the customer, meeting the needs of the exact customer.
Yes, meeting the exact needs of the customer, not the other way around. You said meeting the needs of the exact customer, meeting the exact needs of the customer. And I'm asking, there's a follow-up question that what goes into the exact needs of the customer? If we are to break that further down, the exact need, and that is the word that Leonie used. She replaced the exact needs with completeness. So what is completeness? What is exact needs? What can go into the completeness? What can go into? Okay, Leonie, your hand is up again.
Still trying. Meeting the needs, the exact needs at the specified time, and providing the right quality products or orders that the materials that the customer requested for. Within the
Leonie, today we
specified
are
time.
losing you.
Hello?
Yeah, within the specified time. Hello?
Yes,
Hello,
sir.
Leonie, I can hear you.
Okay.
Yeah,
I said
I can hear you.
providing the right goods within the specified time.
Yes. So meeting the needs of the customer, meeting the needs of the customer in terms of the quantities he or she has placed order for, in terms of the time or delivery time requirement, in terms of the specifics of the product, in terms of the specific of the product. All that goes into other fulfillment. Warehouses. So a warehouse is a commercial building for storage of goods. Warehouses are used by manufacturers, importers, exporters, wholesalers, transport businesses, customs, etc. They are places where value is added to the company's product. How is this possible? How are warehouses able to add value? Yes, class. Anybody? Sadek, your hand is up. Please go ahead.
Okay. I think they add value in the sense that perishable goods and all goods that spoil early. Because of the warehouse, they'll be able to last longer as compared to being in the open.
Okay, but not the exact initial contribution, initial attempts. Well done, but let's improve it. If you go back to something you learned about 10 weeks ago, when we looked at the types of transformation process, can you mention some of the types?
The physical.
So physical transformation, and a typical example is what? Manufacturing. A typical example is manufacturing, correct?
Yes, sir.
Okay. So where will warehouses belong?
Physical.
No, not physical.
Locational.
And locational.
Locational. So to bring the product.
So why
Come
location?
again.
Why location now, sir?
Okay. Who said locational? Come in, help your brother. Oh, I get the reason why. I get a reason why he's asking that question, because for some manufacturing companies, their warehouses are just by the company. Is that the reason why?
Sure, sir. Sure, sir.
Yes, but warehouses are largely away from the manufacturing site. Okay, warehouses are largely away from the manufacturing sites. Wholesalers, for example, will build warehouses where they can consolidate their purchases from various suppliers into the warehouse, and from the warehouse, they can sell it out. And the warehouse comes closer to where customers are, where the buyers of the products are. So that consolidation of different variety of products or different the organization's output into one place where the customer can have access to them, that action is a kind of value-adding activity. And warehouses are now very important because of the concept of supply chain management. Hello, class. Can you? Let's consider there is a delayed this thing today.
I can hear you.
Am I being heard?
Yes, please.
Yes, sir.
Yeah.
Hello.
Hi.
Hello, sir.
Okay, so at least I could be heard. So warehouses are now very, very important. Okay? Look at somebody like delay macro, delay so and so, delay fufu, delay this. Delay is not a manufacturer. I'm sure the manufacturing is done for her in China. I don't think this manufacturing will be done here locally. The manufacturing is done for her in China. And so when the items are manufactured in China and she's bringing them to Ghana, she has to ship them in large quantities. So maybe 40-footer containers, so that their shipment can be economical. She just can't ship a few boxes all the way from China to Ghana. Otherwise, the price of her product would be unbearable. It wouldn't make her products competitive. So to do that, she would have to ship large quantities of these products in terms of 40-footer containers, bring them in. And when they come in, where is she going to keep them? Warehouses. So the current nature of manufacturing, where manufacturing can be located far away in other countries. I don't know whether if I've depicted the supply chain of Apple for you before, but even if I have, let me repeat it. Apple, I mean, they produce a lot of product, but let's focus on the iPhone. Now, Apple is a US-based company. It's a US company, American company. In terms of suppliers who supply Apple with the component, the parts and components which are used in the manufacture of the iPhone, they have over 500 suppliers. Apple has over 500 suppliers spread across the globe. Now, some of these suppliers are based in America. Some of these suppliers are in Canada. Some of these suppliers are in Spain. All the suppliers will ship their parts and components to Apple's assembly plant in China. And then the phone will be assembled in China. After production in China, the final output, which is the phone, is shipped from China back to the US, their warehouses. And then from their warehouses, the phone is then distributed to other parts of the world. You see, that is how manufacturing has become. It doesn't have to be at the same place. So we can separate manufacturing from warehousing. Okay. Up to this point, any question? Okay, no question. And in terms of warehouse management, typical warehouse has thousands of items being stored. And therefore, if you are keeping, let's say there's one warehouse of, say 2 or 3 warehouse operated, it will be difficult for these people to remember exactly where each part is kept. No matter how long they have worked in that warehouse, it will be difficult for them to always remember. They will forget. And this is where warehouse management systems are very important. Automated systems. Automated systems. So an automated system that controls movement and storage of materials within a warehouse. That's what we call the WMS. And it acknowledges that the item is available to ship. It operates as follows: places an item in storage. So when an item arrives in the warehouse, the system finds location for it. Depending on its nomenclature, the system will find a place to say that this item is going to shelf number 21A. And then a human being takes it there. The human being takes it there. Interestingly, in the case of the BMW engine manufacturing plants in the UK, it was so fascinating that it was robots who go to the warehouse. The whole system is operated, is automated. Robots who go to the warehouse. And when the robots get to the warehouse, the item to be picked from the warehouse is picked by another robot and drops it on the collecting robot. And then the collecting robot will pick it and send it to the production floor. See? So that is another example of how warehouses can be automated. If you have time, watch Amazon warehouses on YouTube. And see how they operate them 24/7, highly automated. Okay. And so when an item arrives, the system assigns for placing the item. When an item has to be picked, you punch the item into the system and you are directed to where it is located for it to be picked. Okay. Then we have the last thing, I think it is the last thing. No. Vendor managed inventory, VMI, vendor managed inventory. For me, I see vendor managed inventory as a way of shifting responsibility of storing items to the supplier, But what is VMI? What is vendor managed inventory? It is a supply chain practice where the inventory is monitored, planned, and managed by the vendor on behalf of the consuming organization. Based on expected demand and on previous agreed minimum and maximum inventory levels. If I am a manufacturer, I am supposed to keep my own inventory, and then replenish the inventory as and when there is a need for. I'll look at what I want, buy them, I consume them. As I'm running out, I restock. VMI is a process where we tend to push that responsibility on the supplier instead. So the supplier monitors and the supplier does the planning based on your consumption pattern. The supplier does the pattern and that's the planning, and then manages the inventory you buy. But this will only be restricted to the inventory that you need, that this supplier manufactures or produces. I hope that point is clear.
Yes, sir.
Yes, so not your entire warehouse items, no, or not your entire store items, no. Okay. Maybe a typical, let me give you a typical illustration. You know, Mantrack, it's located around Circle. They deal with earth-moving machines, caterpillar, bulldozers, and excavators, and those machines. They deal with them, and they are the sole representative of Caterpillar Incorporated, US, Caterpillar Inc., US. Now, for some of the mining companies on their premise, and Mantrack also sells spare parts for these machines. So the warehouse at their facility in Accra, they have lots of spare parts for these equipment. So when the part is broken, you go there with a part number, and then they sell one for you. Mantrack also has arrangement with some of the mining companies where Mantrack has set up a store on their premises of these mining companies. Now, what the mining companies will do is that they will come to the store and collect parts as they require. Now, at the end of a period, say a month, Mantrack will look at all the parts and components collected and then bill the mining company. That is a typical example of a vendor managed inventory. But in this case, it will only be the parts that Mantrack deals in. Other parts that Mantrack does not deal in, it will not be the responsibility of Mantrack to keep those parts for those mining companies. It will just be limited to the parts and components that Mantrack deals in. You see? So for you to make sure that you're also delivering a good service, you need to plan how many of these quantities, how many quantities of this part will the mining company need in a month, in a week, in 6 months. So you have to do all the planning, because if there is a shortage, there will be a problem. And you don't want to incur that shortage to create problem for the mining company. Because they have that VMI arrangement with you, they are also not going to buy that part and keep. And so you have to do all the planning as a vendor or the supplier. You have to do all the planning, the management and everything to make sure that consistently, when the mining company comes to that mini store that belongs to the supplier, the parts and components that they have arrangement with you, they will always find it. After all, it's not for free. They will be paying at the end of a period. Up to this point, any question? Okay. So in typical VMI, that's what I've just explained. In typical VMI, the vendor will have a facility on the buying organization's premises. In other places, the vendor may not have any facility on the buying organization's premises. But anytime they need it, the supplier or the vendor will quickly deliver straight to the department that needs it. Straight to the department that needs it, as long as an order is made. Okay. And manufacturers generate orders using data received electronically via media or internet about distribution, sales, and stock levels. It is usually a first step towards supply chain collaboration. Yes. Leonie, your hand is up.
Yes, sir. Please, what's bullwhip effect? Or is it bullwhip?
Bullwhip effect.
I didn't get it.
Bullwhip effect. We've come across it before. Class, Do you have anybody who can help us? Bohip effect. Okay, so it relates to information distortion. Distortion that moves along the supply chain, leading to excessive inventory. Along the supply chain. So there is a small change in the front end, in the downstream end of the supply chain. And as that information is flowing back upstream through the supply chain, because there is no kind of sharing visibility along the supply chain, that information as it moves upstream becomes widely distorted. Maybe I will show you, I'll quickly go there, show you that diagram. That's what we refer to as Bohip effect. It's here. Lenny, can you see the picture?
Yes, sir.
You see, so this is a downstream. This is our upstream. Now, these are the partners that sit along the supply chain. Don't be confused. If anytime you remember the word supply chain, remember the bread example I gave you. You still remember my bread example?
Yes, sir.
Okay. So all the entities sitting there along the bread supply chain, we call those are the partners. And so because they are not sharing information, members cannot see what is happening at the other ends of the chain. I am here. I can see what is happening here because there is a barrier between us. Now, this barrier goes away if my systems are linked to this person's systems. If this person's systems are linked to this person's system, such that when there is a sale, I have a rough idea how many pieces, how many quantities this person is able to sell. Then I can also use that to plan my production. And if you remember, in one of our lessons, we talked about Walmart, having a system where if items are scanned at the spot, the manufacturer of the item far away in Russia, Japan, Australia, receives that same information that one of my products is gone. So in that case, there wouldn't that information flowing back the chain where the information will be distorted as it moves back. That element is eliminated. And just that is what causes the Bohip effect, as you can see here. And Bohip effect is all about supply chain uncertainty. And on the basis of the uncertainty, it leads to that information variability leads to increased inventory levels. And these increased inventory levels create cost within the supply chain, and everybody wants to minimize that. Once supply chain members are able to collaborate, work hand in hand, share information, get connected, these barriers are then broken. So members can see what is happening at the other ends of the supply chain, and they are able to plan with real-time data. Okay. Leonie, can you hear me?
Yes, sir. I think I'm okay.
Okay. So if you are close to me and I whisper something into your ears, and then I ask you to tell whatever I told you, I ask you to whisper that to Sadiq Ahmed, and then you do that. And Sadiq also whispers that to the next person. By the time it gets to maybe the 10th person, you see that variability. So as that information flows back, it will be changing. It will be changing. It will be changing. By the time it gets back, it has changed completely. And in terms of supply chain, that change in that information relates to inventory levels that must be kept to satisfy what is happening at the front end of this chain. Okay. Okay. So we've spoken about the vendor managed inventory. And what are the advantages of vendor managed inventory? One, increased processing speed, computer-to-computer communication, fewer data entry errors, few stockouts for distributors, lower planning and ordering costs for distributors. Distributor order errors are reduced, and forecasting is easier for vendors because they receive distributors' point of sale data. Okay. What is distribution outsourcing? It allows a company to focus on its core competencies. So now, some companies are outsourcing their distribution rather than having my own fleets. It is interesting. I read about Walmart. Look at how huge it is. But because of their objective, operations objective of trying to sell at reasonable price, lower cost, that is their competitive strategy, lower cost. Walmart has its own fleet of vehicles that does distribution for them. So I can imagine the number of vehicles they have. See, but these days a lot of companies are moving away from doing their own distribution. Do we have anybody here working with Accra Brewery Limited? Accra Brewery. Anybody here working with them? I wanted to find out if they do their own distribution or their distribution is outsourced. But I think they will outsource it. And usually companies will do that outsourcing so that they can focus on their core competency. So for a company like Accra Brewery, their core competency is to brew so that people will drink and talk more. And leave the distribution aspect. That is not their core competency. So leave what is not your core area, the reason why your company was set up, leave that to others. Let others worry about. Give it to specialists who own the vehicles. I think it's just like the issue of about 10 years ago when companies used to have their own, not 10 years, about 20 years ago when companies used to have their own vehicles carrying their staff to and from work, staff commuting to work. I remember in those days, Temasto will have its own trucks early in the morning. You see Temasto and their long blue Tata buses. You see Vaco with their staff. You see this company, Aluex, with their staff. But these days, those who live around Tema, do you see those buses? Do you still see those buses? You don't see them anymore, you see, because they have outsourced it to companies like Agate Transport and the rest. That's the same concept we are looking at in terms of distribution. Firms think that, oh, let me just concentrate on manufacturing and get a third party to come in and do the distribution for me. So that is distribution outsourcing. Okay. Any question up to this point? Francis Nathan, your hand is up. Please go ahead.
Yes, sir, please. Assuming that they render service, they want third party to render service for them, that is the outsourcing. In case maybe along the line, maybe they ascend the vehicle and some inconveniences like accident happen on the way and the goods has been destroyed, who bear the cost?
Okay, so all that goes into the agreements they reach. All that goes into the agreements they reach. So the company, let's say Accra Brewery, may force the distribution company to take insurance policy against any of such risks, so that in the event that there is an accident, both the truck and then its load is covered by insurance. But that is here, there is no prescription The company can say that, okay, fine, I can do this, I can do that, but I won't bear that insurance cost. So if you can bear it up, but if you are bearing the insurance cost, I am going to charge you this. If I am going to bear the insurance cost up, I'm going to charge you that. All that will go into the agreement to be raised. Is the question answered?
Yes, sir. Yes, sir. Thank you, sir.
Yeah. And it's a good question you've asked, Francis, because many a times we see, like, even on this motorway, I've seen about two trucks that are involved in accident, that people went there and they were drinking the beer like that. So the question anybody would ask is, whose cost is this? Is it the distributor, and has the distributor taken any insurance, or this truck is coming direct from Accra Brewery? If it's coming from Accra Brewery, is it their truck, or they have outsourced the distribution activity? And so this is a third-party distributor. But all that will go into the agreement to be reached when you are selecting an outsourcing company. Any other question, class?
Sir, please, the reason why I've asked is that, like you see with the accounting,
Yeah.
When you've transferred the risk and the reward, you don't bear it again. Like whenever the goods leave your shop to the listen, you don't bear the cost. That's why I've asked that question.
Oh, I've lost you, Francis.
No, sir.
Yeah, you are on now. Can you come again, please?
I said that there's some organization, they believe that when they transfer the risk to you, they don't bear any cost again. Some of the organization. And with the accounting system, they say like revenue, whenever the person transfer the risk and the reward to you, what happened to the goods again? They don't care about it. That's why I've asked that question.
Okay, I get you. But here it's not like a straight jacket thing. It needs to be specified within the contract. What is the term used? It needs to be specified within the contract, and there has to be an agreement before we know who is bearing which cost and who is not. Okay. Transportation is another key thing when it comes to moving goods from one point to the other. It is a major determinant of prompt delivery service, can be significant supply chain cost, and it can take up to 20% of the total production cost. Now, the major modes of transportation are railways, airways, trucks, waterways, package carriers, pipeline, intermodal transport, internet. Okay. In our country, I think typically what is very common is the truck, isn't it? Is the truck. So we see a lot of these long trucks that we call the articulated trucks, moving goods from the harbor to the interior, moving goods, cocoa, and stuff like that from the interior to the port to be shipped abroad. Our railway system isn't too good for the carriage of goods. It's not even for human transportation. Is someone one still working? The one from someone to Accra, is it still working?
No, please.
It's not working. Okay.
Yeah,
but I've seen recently, recently I've been to Volta region, whole specific, and I've seen a huge amount of railway infrastructure being built. So I think there is a deliberate effort to improve our railway system, and that would help a lot. That would help a lot. Particularly if big cities like Kumasi and Accra can be focused on, so we use that for internal transportation. In other places where we have this park and ride, you come, you park your car, you join the train, you go to work. After work, you come and pick your car, join the train back to where you park your car, you pick it, and then there you go. It reduces our cost of moving goods. These days, I live at Ablekuma. I take my kids to school at Dansoma and then go through Carnation, through Circle, through 37 to Legon. I spend over 2.5 hours, early morning hours, which I could have used productively. I spend those hours in traffic. I think it's a whole lot of headache. But if there is a quick way system where I can, me and the kids will join the train and quickly park my car somewhere, join the train, take them to work after, take them to school after from school. I can also find ways of joining the train to my workplace at Legon. It makes life easier for everybody. I know we'll get there, but it will take us some time. Maybe when you people are in the helm of affairs. Okay. So that's about railway. Air transport, which is good for fragile and very expensive items. Locally, we don't tend to use air transport for goods, maybe for medications perhaps, but largely for human transport. Again, this one too is an area that we are improving. Kumasi Airport is now working towards becoming an international airport. I don't know whether it's already international, where we can have flight from other countries landing straight away there. And that's good. These days you can also fly from Ghana, I said Ghana, from Accra to Kumasi, Accra to Sunyani, Accra to Tamale. Is the whole airstrip working?
Who say?
No, sir. Are you in who?
Say it's not working.
It's not working.
Yes, sir.
Okay, but we pray it works soon so that we can also fly straight from Accra to who? Straight from Accra to who? Yeah. People have money to spend, just that the avenues to spend them are not there. I mean, people can live in Ho and come to work in Accra. I understand some of our Nigerian brothers. You know, we have some Nigerian banks in the country. And some of the chief executives, they live in Nigeria, they come to work in Ghana. 45 minutes, they fly in, come and work, after work, they fly back. 45 minutes. They are done. And internally, we are spending 2.5 hours to do the commuting anyway. Then we have intermodal transport. Intermodal transport is not quite common in our system. But the other day I was doing my checks and I understand that when they are moving fuel, is it fuel? Yes. It gets to Akosumbu or so, and then they move it with the boats. There's a name for the boats, which takes it to the location up north. Anybody with good knowledge in this area? Okay, so intermodal transport is where the movement of a good, a product, goes beyond just using one means of transport. So one, you may use trucks to move it up to a point, and then use train to move it up to the final destination. That would be intermodal. Or you use air to move it from one point to the other. From there, you use ship to move it from that point to the next. It's also intermodal. Then pipeline transportation. Pipeline transportation is also not too common, but we have it in bits and pieces. So for example, when we buy, as a country, we buy our fuel and the ship brings it to Tema. It goes through the pipeline to the depots at Tema. Again, we can also cite the West African pipeline, which supplies gas all the way from Nigeria to Ghana, and I think they said they were extending it to Ivory Coast too also. I don't know whether that has started or that has already been completed, but that is pipeline. That's how we can move goods by pipeline. And then I think with petroleum products up to Akosombo, does anybody know that? Okay, Theophilus.
Yeah, the intermodal and then the pipeline. I'm thinking the pipeline could fall under the intermodal because from the Akusumo to the north, when you cross is it the Black Water? Or when you cross, you see there's a pipeline there, and then the trucks come there to pump it, and then they take it to up north. So I don't know if it should be under the intermodal or it's also something because it goes through the system like.
Okay.
Yeah.
Okay, so in this example, how do we move petroleum products from down south here to the north? In that case, if the explanation you are giving us is what is the practice, then it goes through an intermodal system. So first it is moved from the south, let's say Tema, to which town? Which town? Is it the town we call Maimawata or something?
I've forgotten the name of the town, but I know it's after when you there's a river there after crossing the river. I don't know whether it's the black or white. I've forgotten the name. Yeah, then you see the tracks there. So they pick it from there and then.
The trucks pick it from, so where is the pipeline then?
So like when they deposit it, it goes like it goes through a certain distance. Then they also come and then they pick it.
Pick it, okay.
Yeah.
Okay. So
that I don't know how. Yes. I'm just asking if
I know. I think that I know that there is pipeline transportation along that line, but as to from what point to what point, I don't know. I may need to do a bit of research on that. Yes, but yes, that would be intermodal. However, we can also use pipeline direct to supply without any intervening mode of transportation.
Okay, thank you.
So for example, Holland supplies UK with gas, and there is a pipeline that runs under the sea all the way from Holland to UK, supplying them with gas. I think there is another one from Russia as well, which also lies under the sea pipeline. Okay. And then internet as a means of transport, moving information from one point to the other, moving data from one point to the other. Discuss each of these in terms of availability, cost, volume, and frequency with students. Okay. So in terms of cost, we all know that air is very expensive. Yeah? Very expensive, and it's also good for carrying. Air is not suitable for carrying bulky products. Water, railway are good for carrying bulky products. Road transport or truck is quite common. Their cost is also relatively cheaper. Then we have these package carriers. These days, they're very common on our roads. You see them, expressway, Falcon, this many, they go on motorbikes. Have you observed them? I'm sure some of you even own some of these companies. But some literature refers to them as professional messengers. So people will say, I'm setting up a professional messenger job where you pick parcels from one company to the other. You pick loads from one company, you pick letters from one company and do the distribution for them, wherever it is going to. So package carriers. Does anybody know any package carrier company in Ghana? They work like the big ones like DHL, but they are smaller ones. Okay, Francis, your hand is up.
Then we have the FedEx.
Okay, FedEx yeah, they also work in that industry, but FedEx is one of the big ones. FedEx, UPS, DHL, they are the big boys. But in our country currently, there are smaller ones. Many of them are coming up strongly. They are the ones that these people use. If you buy items on Jumia, they will do the delivery for them. Be observant in what is going on around you. You are doing operations management. Okay. So an important factor in SCM is determining the lowest cost transportation provider from among several alternatives. Because remember, we said transport takes up to 20% of supply chain costs. So if you're able to reduce our transportation costs, we save some money to add to our profit. Now, a quantitative technique that's used for determining the least cost means of transporting goods and services is the transportation method, which you did in management science, which you have already done in management science. All right, so we jump to scheduling, which is our final lecture for the semester. Interesting. See, what if you're a seamstress? Leonie, have you been to a seamstress before? You always go to the mall to get your clothing.
Oh, I've been to seamstress.
Oh, you visit there. You see, and when you go to a seamstress, you go there with your work, and then you have different time requirements. So let's say myself and Leonie, we go to the same seamstress. She goes there yesterday, or she went there yesterday, delivered a workload, and she wants this work to be delivered in 7 days. I went to the same seamstress today. I delivered a work. I want the work to be delivered in 6 days. This is where scheduling comes in, because if you are unable to schedule, many of your works or jobs will get late. And when they get late, it will lead to customer dissatisfaction. And when customers are not happy, what happens? They leave you. And we can all confess, it will take a long time. Oh, as for this seamstress, if you give her a job, it takes a long time for the work to be done. And this is because some of these people do not have this knowledge. You see, to be able to schedule the work in such a way that even if you are late, the lateness will be minimal. So scheduling is an important function when it comes to operations management. So scheduling is the last stage of planning before production. It specifies when labor, activity, equipment, and facilities are needed to produce the product or provide a service. It determines one, which machine a part will be routed for processing or will be passed through for processing, which worker will operate a machine that produces a part, the order in which the parts are to be processed, or which part goes first, which part follows, in which order, which patient was assigned to an operating room. So yes, this is something we are all familiar with. If you go to the university hospital and then you pick your card, they check your card. The next point you go to is you go to where they will take your vitals. They take your vitals, and from that point they will schedule you. Maybe 3 or 4 doctors will be on duty. So the person doing the assignment will look at how many patients he or she has already assigned to each of the doctors. And then they will say, okay, you go to room 4. You see, that is part of the concept of scheduling. Because they don't want to maybe crumble all of you into one room where you're going to be there and it takes a lot of time. Okay, so in order to the order, and then the last one is the order in which a doctor is to see patients. So the scheduling function differs by type of processes and whether it is continuous process, whether it is mass production, whether it is projects. Remember, we have dealt with these already. So if it is a continuous process, we determine the mix of products. And here, linear programming will be very useful. It helps in making the work easier. Determining when to stop producing one type of mixture and when to move on to the next type of mixture. Then, if it's a mass production, determine how fast to feed items into the line and determine how many hours per day to run the line. If it's projects, scheduling decisions are so numerous and interrelated, and the use of paired CPM needed. Paired CPM, we've done this already, you know it. If it's a batch or job shop, scheduling decisions can be complex, and the use of MRP and CRP are very important here. Materials requirement plan. And what is CRP? The customer requirement planning. So we concentrate on issues related to job shop production. In this particular lecture for scheduling, we concentrate on issues related to job shop production and employee scheduling. Okay. So what are the objectives of scheduling? 1, 2, and 3. Meeting customer due dates. Due dates is the dates that the customer anticipates to have his or her work done or delivered. So when we schedule with the aim that we'll be able to meet the dates that the customer requires the item to be submitted. And then the second objective is for us to minimize job lateness, minimize our response time, so improve our response time, that is, get the product to the customer faster or quicker, minimize our completion time, because if you're minimizing response time, obviously completion time is also being minimized. Minimizing the time in the system and reducing overtime, minimizing overtime. Remember, overtime costs money. People who do overtime, they are paid extra. If normal hours is, let's say, 10 cedis, normal rate per hour is say 10 cedis. Overtime is normally paid higher than the normal rate. So if normal rate is 10 cedis, overtime could be 120, 12 cedis, or even 15 cedis. So we minimize overtime. We also minimize idle time and minimize work in progress inventory. Then objective 3 is for us to maximize machine or labor utilization. We want to make sure that the people we have engaged are fully being used. We want to make sure that the machines are operating at their maximum levels. Yeah, we are maximizing machine hours. We are maximizing labor hours. Job flow control, production control. So production control. If there's a scheduling and monitoring of day-to-day production in a job shop through a production department, responsibilities of production control departments. This is the responsibility of the production control department. So let's understand some few terms: loading, sequencing, and monitoring. What is loading? Checking the availability of material, machines, and labor. And load level is needed. Load leveling is making sure that we don't place too much work on a particular machine or individual, making sure that the job is evenly distributed. Okay? Sequencing, releasing work orders to the shop and issuing dispatch lists for individual machines. So release of several orders to one machine center possible. So we release work orders to the shop, and we issue a dispatch list for individual machines. So what each machine is responsible to do. Then monitoring, maintaining progress reports on each job until it is completed. This is where Gantt charts may come in handy. Now, the dispatch list is a short paper that specifies a sequence in which jobs should be processed. Gives you the sequence. You must produce job 1 before job 3. You must produce job 10 before job 6. You must produce job 7 before job 2. That order will give us the dispatch list. So loading, more details. The process of assigning work to limited resources. Each work is assigned to the task that he or she, each worker is assigned to the task he or she can perform best. Each machine is assigned to the job that it can process most efficiently. This is achieved by using the assignment method discussed under linear programming in management science. So once again, you have dealt with this already. Sequencing. When more than one job is assigned to a machine, order is needed. Why is order needed? When you assign more than one job to a machine, you're saying order is needed. Why is order needed? I think today the internet hasn't been too helpful. Because usually you engage better than this. Leonie, can you hear me?
Hello, Doc. My network is not stable.
Okay. Sadiq, your internet appears to be good too. Yeah. Can you help us? On the first point, we are saying that when more than one job is assigned to a machine, order is important. Why is order important?
When more than one job is assigned to a machine, because it's a machine. So machines, they are not, how do I say it? They don't think like human beings. They don't have, their job is to just do a particular task. So if you don't put it in order, it will just do what's supposed to do. For example, maybe, let's say cement making machine, right? Concrete making machine. If you don't put it, for example, you start by putting the sand before, after sand, you put in water. After water, you put in cement. After cement, you put in water. If you just throw all inside, it won't, because the machine is just going around. So if you don't put it in order, you won't get what you want. It will just mess the whole thing up.
Okay. That's a different way of arriving at the same answer. It's good. Okay. Anything in addition?
Sir, please. With the machine, and it uses artificial intelligence. It doesn't have the human intelligence. So sometimes if order, you need to put things in place because you program the machine. Even if you put like with a block machine that you use, if you put let me say Gary inside, it will still miss. It doesn't have the intelligence to tell you that no, this is not what I'm supposed to miss. So you need to put an order so that to follow its sequential order in order to arrive at your results.
Okay. So in other words, the machine needs to do what to do first before moving on to which one. Okay, that is the sequence. Now, prioritizing jobs that have been assigned to a resource. We need to make sure that we prioritize jobs. We need to know which customers want which jobs first, so we can prioritize them to be able to meet customer deadlines. Now, if no order is specified, then the operator may use first come, first serve. First come, first serve. Like, so the jobs that come first, we treat them first before the next jobs that come. First come, first serve. When jobs are stacked, operator may use the last come, first served approach. When jobs are stacked, operators may use last come, first served. You see here, the principle works like when you have a stack of plates, say 20 plates. This one is put on the other. The next plate that comes, you put on top. The next plate that comes, you put it on top. The next plate that comes, you put it on top. So if you start serving the plates, you see that the plate that came first will be the first. The plates that came last will be the first plate to be picked to be served. Do you understand it?
Yes, sir.
And that is why we are saying that when jobs are stacked, the operator may use the last come, first served approach or method. Other sequencing types are earlier due dates and highest customer priority. These are other types that we can use when it comes to scheduling. Let's use the elevator. I am sure we've all used elevators before. If you go to the hospital, some hospitals like Kolebu, if you go to even University of Ghana, yes, our graduates campus, there's an elevator there. How many people does the elevator at the graduate school take? Has anybody observed?
I think
Yeah.
8, right? Is it 8 or 13? I don't remember.
I think it's 8. I think it's 8. Now let's say 8 people are on the ground floor. They are all going to the second floor. So they call the elevator comes, opens, and they get in one by one. Who will be the last person to get in? Where is that person likely to stand?
In front of the door.
In front of the door. So when they get to the second floor, who will be the first person to come out?
The last person to get on.
The last person to get on.
Yeah.
You see? And so that, yeah. So that will work with which of these two principles? The FCFS or the LCFS?
LCFS.
LCFS.
It will work with the LCFS. Okay. All right. So let's move on. So we can, in terms of scheduling, we can use the FCFS, the LCFS. We can use the earliest due date or the highest customer priority. Yeah. As types. Okay. Variations on the earliest due date include what we call the minimum slack. The minimum slack. Now, how do we calculate the slack? The slack is calculated by the due date minus today's date minus the remaining processing time. Don't be confused. We'll work through an example for you to understand it. So slack is equal to the due date minus today's date, all minus the remaining processing time. Then there is another terminology you need to be familiar with. The smallest critical ratio, which is shortened as CR. Now the critical ratio is the time remaining divided by the work remaining. Time remaining, work remaining. And it's the same as due date minus today's date divided by the remaining processing time. Some of these things are formula work, so you need to remember the formula so you can solve them. Okay. Now, if the critical ratio is greater than 1, we say that the job is ahead of schedule. If the critical ratio is less than, you do the calculation here, and what you get, the critical ratio is less than 1, then the job is behind schedule. If the critical ratio is equal to exactly 1, then the job is exactly on schedule, it's on time. We are neither late, neither are we early. Either are we early. Okay. Sequencing jobs through one process. We have the flow time, the mix span, and then tardiness. What is the flow time? Flow time is the time it takes a job to flow through the system. Then mix span, the time it takes for a group of jobs to be completed. Tardiness is the difference between the late job's due dates and its completion time. So tardiness simply refers to how late a job is. How late a job is. Let's look at an example. Can a good reader read this for us? Somebody with good internet. Anybody?
Yes. Because of the approaching
Please go
holiday
ahead.
season.
Go ahead.
Because of the approaching holiday season, Joe Palotti is scheduled to work 7 days a week for the next 2 months. October's work for Joe consists of 5 jobs, A, B, C, D, and E. Job A takes 5 days to complete and is due on day 10. Job B takes 10 days to complete and is due on day 15. Job C, Job C takes 2 days to process and is due on day 5. Job D takes 8 days to process and is due on day 12. And job E, which takes 6 days to process, is due on day 8. There are 120 possible sequences for the 5 jobs. Clearly, enumeration is impossible. Let's try some simple sequencing rules. Sequence the jobs by A, first come, first served. B, earliest due date. C, minimum slack. And D, shortest processing time. Determine the completion time and tardiness of each job under each sequencing rule. Should job processes work as is first come, first served? If not, what sequencing rule would you recommend to Joe?
Thank you very much, Na. Now, are you the Nade I know?
Yes, please.
Okay. Okay. So we are told. So this is typically what those who do jobs, the job shop kind of systems. This is what they do. They get. You have a job, and all the jobs will have different dates. Somebody will come. Oh, I need this in 10 days, please. Another person will come. Oh, you can take 2 weeks to finish it. I don't need it urgently. Another person will come. I need this in 2 days. So here we are going to apply the different sequencing rules. The first one is the first come, first served, which is the FCFS. Then the earliest due dates, D dates. Then the C, minimum slack, which is called the slack. And then D, the shortest possible time, SPT. Sorry, shortest processing time, SPT. Determine the completion time and tardiness of each job under each sequencing rule. So these are the sequencing rules. First come, first served. Earliest due date, minimum slack, shortest processing time. Okay. So we start with the first come, first served. How many jobs are there? The jobs are 5. A, B, C, D, E. You need a table like this. And then the sequencing type you are using is the first column. How many jobs do we have there? 5. Now, because it is first come, first served, and the jobs are in A, B, C, D, we automatically assume that job A came before job B, and job B came before job C, and job C came before D, and D before E. We are just following the alphabet, and that is an assumption we are making here. So The start time here is 0. If you're not given any start time, you start from 0. So we start job A, start time is 0. When is job A needed? Job A takes 5 days to complete and is due on day 10. So yes, it's due on day 10. But what is the processing time? It says, I'm coming. Let's take that again. Job A takes 5 days to complete. So if we are working on job A, it will take us 5 days to complete. But actually, the customer need the job in day 10. So we have the sequencing rule, we have the start time, we have the processing time, we have the completion time, we have the due date, and we have tardiness. These are key headings that you need to take note of. Okay, so we start from job A. Start time, because no time is given, we are starting from 0. Processing time is 5. That is the 5 year, takes 5 days to complete. And completion time is 5, day 5. Remember that we are working in days. So if we are starting at 0, and the processing time is 5. And because it says it takes 5 days to complete, it takes 5 days to complete. So we'll complete it in day 5. However, the job is due to the customer in day 10. What is the tardiness? Are we late?
No, we are not.
We are not. We are not. And that is the 0 days. Tardiness is all about how late we are. Here we are not late, so we put 0 days. Let's go to job B. Job B takes 10 days to complete and is due on day 15. So we write job B here. When are we going to start job B? We'll start job B when job A is done. Job A is completing in day 5. So we can only start job B when job A is done. So we'll start job B in day 5. We'll start job B in day 5. What is the processing time for job B? Job B takes 10 days to complete.
10 days.
10 days. So processing time is 10 days. But when is job B due? Day 15.
15.
Yes. So if we are starting in day 5 and processing time is 10 days, we will complete job B, that is 10 plus 5, we'll complete it in day 15. And coincidentally, that is when the customer needs the job, the same day 15. Are we late?
No, we are not.
No, we are not. No, we are not. Now we go to, we started the month from 0 all the way through 1 to day 15. Day 15, that's where we are now. We move on to job C. Where is job C? Job C takes 2 days to process and is due on day 5. Job C comes in. Remember, job B finishes in day 15. So it is when we are done with this that we can start job C. So job C starts day 15. It takes 2 days to complete. If it is starting day 15, 2 days to complete, we are completing the process. We are completing job C in day 17. But when is job C due? From the question.
For 5 days.
Job C is due, it's due on day 5. It's due on day 5. Meanwhile, we are completing it on day 17. So how many days late?
12.
12 days late. Let's go to job D. Job D from the case takes 8 days to process and is due on day 12. 8 days to process job D. So when we are done with job C on day 17, that's when job D will start. So we start and it takes 8 days to process. So we add that 8 days to the 17, we have 25. So we are finishing job D day 25. And it's actually, the customer wants it on day 12. Meanwhile, we are completing it on day 25 for the customer. how many days are we late? Tardiness is 13 days. And then we come to job E. Job E can start when we are done with job D on day 25. So day 25 comes here. Processing time is 6 days. We add the 6 days to this and we have 31. The good news is that all the jobs we received, we've been able to complete it in 1 month. Nadia, your hand is up.
I was going to say, is that a question will ask us a case where some jobs can run concurrently?
No.
Okay. All right. Thank you.
One job at a time. All right. So job E, the completion time is day 31. When is it due? The customer actually wanted it day 8. We are finishing at the end of the month, day 31. So we are late for 21 days. It's important for you to calculate your average tardiness. It's important for you to calculate your average completion time. Because remember, one of the objectives is that we want to minimize the processing time. So we want to know the average completion time, the time it takes to get the jobs done. And then we also want to know the average tardiness. So here you always need to compute these averages. It will be the key decision points. You look at this to make decisions. Okay, let's go to, so this is the first sequencing type, FCFS, first come, first served. And this is how the jobs will be arranged. This is how we'll process them. And this is the extent to which some of the jobs may be late. After this, we move on to the earliest due date. Now, here, what do you think we'll be doing? Earliest due dates. Nade, your internet is good, so please respond for us.
Sorry, please, the question, this said what's the earliest due date?
No,
10.
So in earliest due date, what do you think we'll be doing?
We'll be choosing the minimum due date, I think.
Come again, improve it a little for us. Here, first come, first served. A came first, so we treated A first. Next B, we treated B. Next C, we treated C. So if that is the order, what do you think we'll be doing with earliest due date? Anybody?
So we do the earliest due date first.
We'll do the earliest due date first. Okay. So jobs which are needed quicker. Yeah, we arrange the jobs according to how early the customer wants them. You see? So if you look at here, these are the due dates. These are the due dates. So if we are going to do the earliest due dates, if you are going to follow the earliest due date sequencing, which of these jobs are we going to treat first?
C.
C. Then the next one will be
A.
The next one will be what?
Oh, no, E.
E. Then the next one will be what?
A.
A. Followed by
B.
D.
A, D, and B. Yes.
And then we come to this. Yes. So over here, you arrange these jobs according to this order. Now let's go there.
Okay.
So earliest due date sequencing type. So this is the sequencing due dates sequencing. From the due dates that we have from the question, 5 is the first one. Again, we are not giving any dates, so we are starting from time 0.
Okay.
And what is the processing time for? What is the processing time for job C? Is 2 days.
2.
So we treat that, and completion time is day 2. When does the customer need it? The customer needs it in day 5. Are we late? No, we are not. What? Yeah. When we then the next goes from 8 to from 5 will go to the next will be job E, which will start when we have finished with job C. So G starts in day 2. What's the processing time for job E? It's 6 days. We complete in day 8.
Day 8.
When does the customer want it? The customer wants it in day 8. Are we late? We are not late. We are not late. Yes. And the next due date is 10, yeah? And that is activity A or job A. Job A will only start when we have finished with job E. Job E finishes in day 8. So we start job A in day 8. What's the processing time for job A? It's 5 days. So if we add a 5 to the starting date, which is day 8, we complete the job in day 13. When does the customer want it? The customer wants it in day 10. Are we late? Yes, we are late.
By 3 days.
Yes, we are late. Yes, we are late by 3 days. We are late by 3 days. Then the next due date is 12, and that is the job D. Job D can only start when we have finished with job A, which is the 13. So the 13 becomes the starting time for job D. What is the processing time for job D? Is 8 days. 8 plus 13, we finish job D in day 21. Day 21, when does the customer want this job? The customer wants it by day 12. Meanwhile, we are completing in day 21. Are we late? Yes, we are late. By how many days? By 9 days.
9 days.
Then the last one is, the due date is 15, which is job B. We can only start job B when we are done with job D, and job D completes on day 21. So that will be the starting time for job B. What is the processing time? 10 days. So we'll finish in day 31. Thankfully, we are finishing all our jobs again over here in 31 days, the same month. Okay? And we sum this up to get 75. We sum this up to get 28. We take the average. Remember, I said the average is an important decision point. So we take the average completion time, average tardiness. On the average, how many days are we late? Then we'll go to the shortest processing time. Remember, this is where students often get confused between the two, the earliest due date and then the shortest processing time. Note, they are different. This is the due date. This is the processing time. They are not the same. The processing time is the time it takes to get the activity or the job done. And the due date is the date by which the job should be completed. So the two are not the same. I'm saying this because in the past, it gets to these two and it sees students fumbling, taking processing time to be due date and due date to be processing time. Okay, I can see some 2 hands up. Francis, do you have a question?
Yes, please.
Please go ahead.
Say with a C. You see, doesn't mean that negative doesn't exist. Because I can see 2 plus 2 is 4. 4 minus 5 is supposed to be -1, but I saw that you put in 0 or you input 0 at the tardiness.
Okay. The tardiness, that's why I have explained the tardiness to you. The tardiness means how late are we? That's why when I get to this point, I will ask the class a question, are we late? If you say yes, we are late, then you ask by how many days? Are we late? No, we are not late. Then you put 0 there. So there is no negative.
Thank you, sir.
Okay. Then let's come to the shortest processing time. So this is the processing time. The shortest is 2, followed by 5, followed by 6, followed by 8, followed by 10. So we treat this one first. And again, it is the same job C. When are we starting? We are not given any starting time. So we start from 0. What is the processing time? 2 days. So we complete that job in 2 days. When does the customer want it? The customer wants it in day 5. Are we late? No. So put 0 there. Then the next lowest processing time is 5, and that's activity A. So put activity A there. When can we start activity A? Day 2. That's when we have completed activity C. So day 2. What's the processing time for activity A? 5 days. When are we expected to finish activity A? 2 plus 5, that would be 17. 17, oh, sorry, 2 plus 5, which is 7. Day 7, that's when we'll complete it. When does the customer want it? The customer wants it in day 10. Are we late? No, so we'll put 0 there. Then the next processing time, lowest processing time is 6, and that's activity A. We'll start activity E when we are done with activity A. So activity E starts day 7. What's the processing time? 6 days. So 6 days, starting day 7, we'll complete it in day 7, day 13. Day 13. When does the customer wants it? The customer wants the job on day 8. We are finishing in day 13. Are we late? Yes, we are late. By how many days? By 13 minus 8, and that will give us 5. 5 days. 5 days. Thank you, Nadi. Then the next is lowest is 8, which is activity D. Activity D can only start when we are done with activity E, which completes on day 13. So activity starts day 13. What's the processing time? 8 days. 8 plus 13 will give us 21. 8 plus 13 will give us 21. So we'll finish activity D on day 21. When does this customer, Nadi, in fact, this one, the customer is Nadi. She actually wants this dress for a wedding on day 12. Meanwhile, we are finishing the job for her on day 21. Are we late for Nadi? Yes. By how many days? By subtracting 12 from 21. And that will give you, Nadi, how many days are we late?
9 days, please.
9 days. So that wedding,
every day is 500 cities.
So that way, then forget it, we are late. Then the last one, based on the shortest processing time, is day 10, and which can only start when we are done with the previous activity on day 21. So job B, which is the last, starts on day 21. What's the processing time? It's 10 days. So if we are starting here, day 21, processing time is 10 days. We'll finish on day 31. Again, this sequencing method has also enabled us to finish all the jobs within 1 month. We go through day 31. When does the customer want the job? Day 15. The customer wants it day 15. We have finished day 31. We are 16 days late. And it's 16 days because 31 minus 15 will give you 16. We sum the lateness up, then we take the average. We sum the completion times up, then we take the average. We take the average. Let's go to the next one. The Slack method. So the Slack method, remember we said the Slack, it says, what is the due dates minus today's dates? Remember, we are not giving today's date, so we assume that today is day 0. If we are not giving today's date, in some cases, you may be giving today's date as today is day 3 or today is day 4. But in this case, we are saying that you've not been given any today's date. So using the Slack method, we do the subtraction. Due dates. Job A is due in 10 days minus today's date. Today is 0. So 10 minus 0 minus the remaining processing time. Processing time is 5 days, 10 days, as we already know, the same processing times. So 10 minus 0 minus 5. So this will be 5. Job B, due date is 15, day 15. Today's date is 0 minus the processing time, which is 10. That will also give you 5. So you do the subtractions and you have 5, 5, 3, 4, 2. Okay. Now there is a tie here. This is 5, this is 5. So which one will be done first? We say that you break the tie arbitrarily. So you can choose to do any of the first. It doesn't matter. It doesn't matter. So 5 is, we start with your the shortest. Remember with the slide, we look at the minimum. We start with the minimum. So the minimum here is 2. And that is activity E. So we start processing activity E first. Starting at day 0, processing time. What's the processing time? 6 days. So 6 days, we finish in day 6. When is that work due? The work is due in 8 days. Are we late? No. So if we are not late, we put 0 there. Then the next minimum from 2, where do we go to?
3.
So 3.
We go to 3. So we pick activity C. So activity C comes next. When we are done with activity day 6, C starts day 6. What's the processing time? 2 days. So we finish in day 8. We finish in day 8. When does the customer want this job? The customer wants this job in day 5. We are finishing in day 8. Nade, are we late? Francis, are we late?
Yes, please.
How many days are we?
3.
3 days, because 8 minus 5 will give us 3. And so you go on in that order, taking from the least to the maximum. Okay? Now, when you get to this point, A and B, like I said, because there is a tie, you choose them arbitrarily. Somebody can choose to do A first. Somebody can choose A before B or B before A. Again, you sum up your completion time, and then you take the average. But let's go back to the question. The question says that, what sequencing rule would you recommend to Joe? What sequencing rule would you recommend to Joe? Now, this is for explanation, so we haven't given you the basis for you to make your decision. But as you can see, we are taking the average completion times, we are taking the average tardiness. So the question could have been, on the basis of the average tardiness, which sequencing rule would you recommend to Joe Pallotti? On the basis of the average tardiness, which sequencing rule would you recommend to Joe Pallotti? So you create this. Leon, your hand is up.
Oh, no, sir, it's okay.
Sorry?
It's okay.
It's okay. All right, thank you. So all the rules that you have worked on, and remember, when this something like this is to come in the exams, definitely we are not going to give you just 1 or 2. We'll give you 3 or 4. So you solve and then make a recommendation. So the average completion times 18.60, 15.00, 16.40, 14.40. You see, the lower the better. Over here, the lower the better. The figure, the lower the better. Then the average tardiness. On the average, if we are using the first come first serve, jobs are on the average tardy by 10 days. D dates, jobs are on the average 6 days study or 6 days late. This on the average, using the slack method, jobs are on the average 7 days late. And here, jobs are on the average 6 days late. Then number of jobs that are tardy. So 3, 3, 4, 3. And maximum tardiness. Maximum tardiness, if you look at this, if you look at the tardiness column, your maximum here is 16, 16, 16, and 23. and 23. Oh, sorry. Where is it? 20, where did we get a 23? Yeah, over here. So 20, the maximum figure here is 23. That's the maximum tardiness, 23. Over here, the maximum is 16. Over here, the maximum is 16. Over here, the maximum is 16. So those are the maximum tardiness. So in an exam, we would ask you that on the basis of the average completion time or on the basis of the average tardiness, which of them would you recommend to Joe Pallotti? As if we say on the basis of the average tardiness, which of them would you recommend to Joe Pallotti? Which is the lowest figure here? It's 5.6. So you recommend the due dates. We can also ask on the basis of the average completion time, which would you recommend? And you say SPT because it has the lowest of 14.80. 14.80. Up to this point, class, any question? Francis,
No,
your
sir.
hand is up.
Sir,
Okay.
please, with
Yes,
the Slack, you made mention that anytime today's date is not given, you mean the default is 0. Anytime we have a question is being posted in the exams and probably today's date is not given, the default is 0.
Yes. Yes. Okay, thank you. So let's say in the
Excuse me,
question.
sir, I have a question.
Go ahead.
Yeah, what
Please.
about a case where you have a tie? How do you recommend?
You mean on the summary table?
Yes, sir.
Okay, so you can say that on the results indicates that, okay, let me go back. So let's say we're asking you to make a recommendation based on the average tardiness. Okay, let's say we're asking you to make a recommendation based on the number of jobs studied. And
Yes,
for
sir.
here, yes, you have the same number of jobs for 1, 2, and 3. So you can say that all of them have the same number of jobs studied. So there is no job with a particular strength. On that basis, you can choose any of them with the lowest, with the minimum, which is the 3. So with all 3, which is the SPT, the FCFS, and then due dates cannot be recommended.
All right. Thank you.
Okay. Thank you. I want to give you an instance where we're asking so in this question, if we had said that today's date is day 2, or let's say today's date is day 3, then the starting day is not going to be 0. We said over here, where if you can see my cursor, today's date is day 3. Then in that case, we are starting day 3. Processing time is 5. You add a 5 to the 3, and it's going to give the completion time is going to be day 8. And then it goes on and on and on. But where that today's date is not given, then we assume that, like Francis said, the default is 0. You're starting from 0. Okay. Sequencing jobs. We have 3 more slides and we are for today. We are almost done. Sequencing jobs through serial processes. Most factories consist of more than one process. So a job may have to go through 2 processes. And therefore, we need techniques that yield optimum sequence of jobs processed through more than one process or machines. And when it comes to a situation like that, what we call the Johnson's rule is the most appropriate or the recommended technique. Johnson's rule. And what would the Johnson's rule do? The Johnson's rule will first find the fastest way. It will find the fastest way to process series of jobs through a 2-step system. It finds the fastest way to process series of jobs through a two-step system. Two-step system is where you have two processes to get a job done. So typically in a welding shop, you may have to do the welding. That is the first step. And then the second step is that you have to spray them, spray the metal you have welded. So that will be two sets of processes, welding and then the spraying. So every job you weld every job that goes through the first process, which is the welding, must also of necessity go to the second process, which is the spraying, to get it painted. Maybe another word, painted. See. Let's have an example here. Okay, we are not there yet. So Johnson's rule says that we list the time required to complete each job at each process. Then we set up a one-dimensional matrix to represent the desired sequence. Take note, one-dimensional matrix to represent the desired sequence with the number of slots equal to the number of jobs. So you draw a long rectangle, and you divide the rectangle into number of slots or boxes covering the number of jobs available. So the long rectangle, if there are 6 jobs that we are looking at, you divide the long rectangle into 6 boxes, and each box is going to represent a slot for a job, Then we select the smallest processing time at each process. Remember, we said 2 processes, process A, process B. So we select the smallest processing time at each process. If that time occurs at process 1, we put the associated job as near to the beginning of the sequence. The sequence here, we are referring to the one-dimensional matrix you have drawn and divided it into the number of slots in terms of the jobs that you have. So we put it, if it occurs in process 1, we put the associated job as near to the beginning of the sequence or the matrix as possible. So the beginning of the matrix is represented by process 1, and then the ending part of the matrix is represented by process 2. Okay? If it occurs at process 2, we put the associated job as near to the end of the sequence as possible. Remove the job from the job list which you have created here. Repeat steps 2 to 4 until all slots in the matrix have been filled or jobs have been sequenced. So let's take a look. Nadia, let's go.
Johnson's Fine Restorations has received a rush order to refinish 5 carousel animals.
It's not council.
An alligator, pardon?
It's not council.
Carousel animals. I didn't say council.
Okay.
An alligator, a bear, a cat, a deer, and an elephant.
Okay.
The restoration involves 2 major processes, sanding and painting.
Okay.
Mr. Johnson takes care of the sanding. His son does the painting. The time required for each refinishing job differs by the state of disrepair and degree of detail of each animal. Given the following processing times and hours, determine the order in which the job should be processed so that the rush order can be completed as soon as possible.
So how many processes are here involved in this kind of activity? Two processes. The first one is what?
Sanding.
Sanding. So we sandpaper the animal. And then the second point, after sandpapering the animal, it will go to the second
painting
process,
for painting.
Painting. So Mr. Johnson will do the sanding. His son, Ali Baba, will do the painting. So these are the jobs. Okay. Job A, B, C, D. Processing time If job A is in process 1, it takes 6 minutes. Oh, it's in hours, sorry, it's in hours. So it takes 6 hours before it gets completed in process 1. Then it goes to process 2, where it takes 8 hours. Job B goes into process 1, it takes 11 hours. And then after process 1, it goes to process 2, and it takes 6 hours. Job C, 7 hours in process 1, 3 hours in process 2, and in that order. So this is the situation you have. And we are saying that using the Johnson's rule, determine the order in which these activities, these jobs should be completed, should be done, so that it will be completed as soon as possible. And remember, we said that Johnson's rule enables jobs that go through more than one process to be completed in the fastest way possible. Okay? So let's see what we need to do. So this is the one-dimensional matrix. One-dimensional matrix. How many, and this is what I call the long rectangle. How many boxes is the long rectangle divided into?
5.
Why have we divided it into 5? Why have we divided it into 5?
I think we have 5
because we have
jobs.
5 jobs.
Because we have 5 jobs. Because we have 5 jobs. Assuming we have 10 jobs, how many boxes are we going to have here?
10.
We'll have 10. We'll have 10. Okay. And then, so the rule says that we list them according to list the times required to complete each job at each process. We have that in the table. Set up a one-dimensional matrix to represent the desired sequence. And then we select the smallest time. So we pick the smallest time at a time. And we look at where that time occurs. So if we look at this, where is the smallest time occurring? Look at this diagram. Where is the smallest time?
Process 2.
Where is it? Which job?
C, job C.
Job C.
hours.
And in process 2. Okay. Job C and in process 2. So this is the smallest. So we go to our one-dimensional. The beginning here, by default, represent process 1. And then the ending here, the end here, by default, represent process 2. So we go through the list that we have. So job C, process 2, 3 hours. That is the smallest. So we put job C close to the end because the end here represents process 2. The beginning represents process 1. So we put C here. We go through again to look, we go through again to look at the next minimum. From 3, which is the next minimum?
5. Process E, process 1E, yeah.
And that is job E in process 1. Okay, so we pick job E and put it close at the beginning of the matrix. So job E comes to fill the next box. We're putting it here because it's in process 1. If the job is in process 1, then you put it close to the end, beginning. If it's in process 2, you put it close to the end. Now we're done with the job C. So let's go to the next. From 5, job E. What is the next minimum?
6. Process 2B.
But 6, is it only 1?
No, we have one for A and then one for B, process 1 and 2.
Aha. 1 for, so 6, you have it for job A in process 1, and you have 6 for job B in process 2. Now we pick the A, this is in process 1. So we'll pick A and put it next to E. So we pick the A, put it next to E. Yeah. And then we'll go back. The other 6, which is the next, is B, but B is in process 2. So we put it close to the end of the matrix. So put B close to the end of the matrix. We only have one box outstanding, and we know there is one job remaining. What is that job?
D.
D. So we put the D in there. And so this is the sequence. This is the sequence that we should process the jobs. By Johnson's rule, the job should go through process 1 using this process. And they should also go to process 2 following the same order. Following the same order. Okay. Let's go to the next. So write this one's that okay. You even need to write it. Where is the table? Okay, so we are dealing with the process 1, and then we'll move on to process 2. Let's go here. So job E, how many hours? 5 hours. That is the first in the matrix, 5 hours. Now, when job E is started for the first 5 hours, do you think process B will be doing something? Sorry, process 2. Do you think process 2 will be doing anything?
No,
Why no?
because they have to finish with the process 1 before process 2.
Because we have the job has to go through process 1 before it goes to process 2. And job E is the starting point in process 1. So at that point, there is no job in process 2. So the first 5 hours in process 2 becomes an idle time. So job E, 5 hours it is done. So it jumps to process 2, starting at hour 5. When we are done with job E in 5 hours, the next job is job A. How many hours is job A? Is it 6 hours? Job A, how many hours? 6 hours. In process A, it's here.
Yes.
6 hours. So we continue the next with 6 hours. 6 hours, job A, and that will be hour 11. But you see that when job E enters process 2, when job E enters process 2, it's a whole 10 hours. So any job within that 10 hours, any job that we complete in job A will have to come and wait. It will have to wait. So even though job A finishes in 11 hours, it cannot move to process 2 because at that time, process 2 is still active on job E. So it will only join process 2 in hour 15, even though we finished it in hour 11 in process 1. Again, when we are done with job A, we go to D. D is about 9 hours. Processing time in process A is 9 hours. So when it also finishes in hour 20, at that moment, process 2 is still active with job A, which finishes in hour 23. So it will wait for about 3 hours before it enters process 2. Then we get this job B done. That joins. Look at here, it's quite interesting here. When job D enters process 2, we finish that in 7 hours. But B, which joins process A in hour 20, finishes in hour 31. So which means that process 2 will be idle for 1 hour. It will be there doing nothing because at that time, there is no job to be processed until job B is finished in hour 31, and then it enters in hour 31, and it goes on, okay? So overall, the job completion time will be 41 hours. 41 hours. 41 hours. of process 1. So the completion time for the set of the 5 jobs is 41 hours. Note that although Johnson's rule minimizes mixed span and idle time, it does not consider job due dates in constructing the sequence. So there is no attempt to minimize job lateness. That is one deficiency with the Johnson's rule. It doesn't take into account. It doesn't take into account how soon the customer wants the job. So that becomes a problem. But it enables the jobs to be completed in the fastest way possible. Fastest way possible. Up to this point, any question? Up to this point, any question? So we are done. We've come to the end of our lessons for the semester. Okay, class, any question? Let me start. Okay, so I guess there are no questions. I've already spoken about the exams already. Unfortunately, I am unable to give you any areas, because if I do, I may be deceiving you. Just because we have not set the questions yet. We will set the questions. I keep saying we, because production and operations management is not taught by one lecturer. It is taught by 3 lecturers. Myself, Dr. Fodaze, and Dr. Banoro. So we share the course and we teach. When it comes to setting of questions, I'll set we'll divide. Now, okay, these are the topics we have taught the students. Joshua, you take 2 topics and set questions on them. Dr. Fodazi, take 2 topics and set questions on them. Dr. Banuro, take 2 questions and set questions on them. Okay, and then when we are done, we assemble the questions and then we give it to you. We haven't done that yet, so I'm unable to tell you that look at these areas or look at that areas. That is a challenge I have. But whatever the case, just master all the calculations that we have taken you through. And in case any comes, any drops, you will be able to do them. Any comments? Yes, sir, Enoch.
No, please, I'm not talking.
Francis Netam, your hand is up.
Sir, please, it's a question, but it's not related to today's topic.
Okay.
Sir, please, is there any difference between outsourcing and subcontracting?
This question has come up over and over again. You see, I think the book we are using apply the term somehow interchangeably, but outsourcing is when you give out a job that used to be done internally, a job that used to be done in-house. You give it to an outside provider to come in and deliver that job for you. Okay? So in a home, the woman does the laundry, the woman does the washing of the family's clothing. That is a job that is done in-house. That up to a point, the woman decides that, oh, it's taking a lot of my time. It's not my core business. I've not been married to come and do washing. It's not my core business. My core business is to focus on making sure I produce kids, so giving birth, making babies. Let me the non-core activities out. Then the woman decides that, okay, he's going to bring in Auntie, who is a specialist, somebody who does laundry. What is the name? Any idea? I don't know the name myself. And the woman brings in somebody to come into the house and do the laundry every Saturday for them. That is a typical illustration of outsourcing. See, in times past, companies used to have their own hospitals. They employ their own medical doctors. You see, manufacturing companies in Tema, they were in competition. They had their own hospital within their facility. They employed their own nurses, they employed their doctors. But along the line, they realized that no, this is waste of money. We are not into business to provide good health for our staff. So why don't we leave that out to organizations that have the specialist capacity to do so? So companies started closing down their medical facilities, and then they decided that they will look for outside providers. So a company like Yahoo has engagement with a lot of organizations, so that if you are working for commercial, I don't know whether commercial bank they do attend Yahoo. If you are working for commercial bank and you are sick, you go to Yahoo and you are looked after. Yahoo sends a bill to your friend saying your company and your company pays. Where my wife works, their clinic, I mean, they have an arrangement with Northwich Clinic, and it covers even the spouse and then I mean, you know what I'm talking about. So your companies don't really have to own medical facilities. They now give it to hospitals, clinics to provide you your health needs. That is outsourcing. What is subcontracting? Subcontracting is where for some reason, a job which is contracted out, the main contractor will bring in a subcontractor. So I give you a construction job to put up, let's say, our new headquarters in Accra. You're a contractor. You can also subcontract part of the job. Maybe the metal works in the building. As a contractor, you don't have the capacity for metal works. So you can also subcontract the metal work in the building to a metal work specialist to come in and provide that job for you. Is it clear?
Yes, please.
Sometimes too, you may get an order which is too much for you. You may decide that you will subcontract part of that order. Part of that order. So probably somebody has ordered thousands of sachet water from you, and you don't have the capacity to produce all. You can go and give your branding to, and let's say you are Belacqua, you can go and give your branding to what is the name? Special Ice to produce the water and then bag it in your branding for you. That can also qualify as subcontracting. So you give part of the job out for somebody to do for you. Okay. So if you understand it, then we can move on. Class, any other question? Any other question? Bismarck, any question?
No, sir. Sir, please. My question was on the areas, but since you said you've not said the question, so
yes,
we can't continue.
I'll be very honest with you. We haven't.
Okay, sir.
We haven't said the question. But the areas we tend to cover. Once again, let me just bother you with this.
Okay, sir.
This thing I shared. Where is it? The US government. This one. So project management, we tend to ask questions on project management a lot. And this one, for example, was on crashing. This one was on crashing. So the Consolidated Bank of Ghana is planning. So project management, we tend to ask a lot. Master it. Look at it without the crashing and with crashing. Make sure you are competent in resolving, providing solutions to problems in that area. And then process selection. Process selection too is one area where we tend to ask a lot of questions. Let me see here whether we did ask a question on process selection. So this is on process layout. Process layout. This is on yield management. Yield management. Aha. Another area we frequently ask questions. Capacity and aggregate planning. Capacity and aggregate planning. We tend to ask almost every year we ask question on that area. See? I'm sure some of you are taking snapshots. We have never repeated a question before, so don't worry.
I believe that the solution was help us, then we would also work alongside.
Come again.
I said some of the solutions will be helpful to us because we want to work alongside.
Okay. Okay. Leonie, your hand is up.
So please, under the capacity aggregate planning, can you please go through the mix strategy? I'm a little bit confused. I don't know. I don't understand that one very well. For the level production planning, I understand, but the mix strategy, I'm a little bit confused.
The mix strategy is where you are giving, the data tells you that you can subcontract some work and you can do overtime. And they tell you the order in which they occur. You can produce or you subcontract or you do overtime. And all of them, they give you the limits. They give you the limits, okay? So let's say, what is the biggest figure right here? This is 200,000. Let's say we are doing, our production level is 200,000 and our workers, the maximum number of workers we can available can only produce 100,000. How do we fulfill the other 100,000? So you look at the option given to you, and then you look at it. If I subcontract, will subcontract satisfy all my requirements? If you subcontract the full limit of subcontracting as per the data given, will the remaining requirement of 100,000 be fulfilled? If not, then you move on, you subcontract parts, and then you move on to the next of, maybe if it's overtime, you do the rest on overtime. So you need to apply, look at the order in which the question, look at the information provided in the question and use that to resolve, deliver your solution. I don't know whether in this case we have, let me see. The Kintampo Tourist Resort is one of Ghana's best holiday centers and sells a special type of souvenir called expensive. As you might expect, a demand for expensive is highly seasonal. As tourist centers exhibit a highly seasonal attraction pattern with peaks during the summer months. The following forecasts are available for expensive. Inventory carrying costs, 3 cedis per piece per quarter. Production per employee, 1,000 pieces per quarter. Regular workforce, 50 workers. Cost of regular production, 50 per piece. Hiring cost per employee, 7. Hiring cost per, so this has nothing to do with a mixed strategy. Mixed strategy. Okay, another type of the mixed strategy could be where we tell you that, yes, this is what we have. If you are producing per quarter, if this is what you are producing, what would be the total cost? So in that case, per quarter, we will give you how much you are producing. And so this is the sales forecast. Yeah. And we will say that, okay, you are producing for quarter 1, you are producing this. For quarter 2, you are producing that. For quarter 2, you are producing this. For quarter 3, you are producing that. We'll give you that information. And that can also be applied in terms of the mixed strategy. That can also be applied in terms of the mixed strategy. Unless I have typical example for us to go through, I think the explanation will be a little unclear. Let me see. No, usually it's one question per one topic per question. So we wouldn't have any other example here. But if you need, has my TA taken you through, hasn't he taken you through the mixed strategy?
So we did.
You did. And Leonie, you are still not clear, correct?
I missed that lecture.
You missed that lecture. Okay. If make an attempt to read, if you still don't understand it, in the course of the week, if you can come to campus, I don't mind spending 1 hour with you to help you understand it.
Thank you, sir.
Okay.
Yeah, Leonie and Nadia will come.
No problem at all. I love to see your beautiful faces. I think I saw your face just once and that was it. So I don't, for a lot of you, I don't know you. I remember Nadia was sitting in front, the first seat. As for Leonie, I don't even remember the face. Cry. Okay. So the topics that we frequently ask questions on, that's what I'm trying to point out to you. This is question 2. This is question 1. And this one too. This one too, we frequently ask questions on it. So class, I wish you all the best and just ensure that you put up your best. Okay?
Thank you, sir.
Thank you.
On that note, I'll call it. I'll pull down the curtains on the semester. Yo, thank you.
So please, what's the grade system like? Is it 50-50 or 70-30?
No, for production, it's not going to be 70-30. It's going to be 50-50.
Okay.
And so for you, what I've done is, you know, you did one assignment for me, physical one.
Yes.
And you did quiz 3 You did quiz 3 and quiz 4. I'm going to use quiz 3 and 4 to replace 1 and 2. Quiz 3, quiz 4 will give you 80%. Then I will add the assignment which you did in class. That will be 20% to give me 100. And out of that 100, I'll take 50. I'll take 50%. Then the examination is going to be over 100. So whatever you score, I scale it down to 50. If you score 80 over 100, I scale it down to 50 to give you 40. If you had already gotten 80, if you had already gotten 40% in a continuous assessment, we add your 40 to it and you have your 80 to give you the 8. So that's how it is going to go.
Okay.
Continuous assessment, 40, 40, 20 to get a 100. Then I strike the average to get 50%. End of semester is over 100%. I strike the average to get my 50%. Add it to the average in the continuous assessment to get the overall assessment. Any other question? Okay, so thank you for your time and everything. I wish you all the best.
Thank you. Wish you all the
Thank you
best.
too.
Okay.
Thank you, sir.
Bye.